Welcome back, guys. I hope all of you will be fine. So today we are going to start another chapter, which is chapter number 2, and that is related to the probability. Okay, so first of all we will go through all the fundamental concepts of the probability, and then we will try to solve all the questions one by one. Okay, so this is question 2.1, which is asking us to list the elements of each of the following sample spaces. Okay, so statements have been given here, and on the basis of these statements we have to list the sample spaces. Okay, so in order to list those sample spaces, let me choose the color this blue. Okay, and for the part A here, the set of integers between 1 and 50 divisible by 8. Okay, so we have to write all the numbers which are divisible by 8 from 1 to 50. So therefore let me start writing them. Okay, so at the start of a sample space I have to write this, I have to put this curly brace. Okay, and at the end of it I also have to close it by using another curly brace. Okay, so the first number here will be 8. Okay, that is between 1 and 50. The other one will be 16. The third one will be 24, 32, 40, and the last one here would be 48, and then we have to close it. Okay, and in between each element here I have to put a comma here. Okay, so that is basically the method of writing the sample space. Okay, so that is the sample space which is defined by the statement given in part A here. Similarly, part B, the set of S equal to X such that X square plus 4X minus 5X equal to 0. So let me choose this color for it. In order to do so, let me start it here. So in starting it here and solving it here, so the solution of part B, I have to first write this equation here, 4X minus 5 equal to 0, and after it what I have to do, let me factorize it. So in order to factorize it, let me write it x square plus 5x minus x minus 5, that is 0. Okay, so that would be x plus 5 and minus 1, x plus 5 equal to 0, which will ultimately give me what? X minus 1, x plus 5, that is equal to 0, and which will ultimately give me the values of x which are equal to what? 1 and minus 5. Okay, so these are the two values. So let me write these values here, and the values of the set here will be S, and that would be what? Those would be only two values which we have calculated right now. Okay, so that is now S equal to 1 minus 5, and the same rule which we have followed here will also be followed here. Okay, the set of outcomes when a coin is tossed until a tail or three heads appear. Okay, so in this part we have to see the coin tossing again. Let me write tail for T and heads is for heads. So the first outcome will be T, the other one will be HT. Why HT? Because now we can see that first heads had occurred and in second tail has occurred. So we have to end this process. Similarly, heads. Okay, so we have to wait for the third outcome, and here tail has occurred. So this is the third outcome, and similarly in fourth outcome we have to wait for the tails or the three heads. So when either tail or three heads appear, we have to stop there. So the third outcome will be here, and here three heads have been occurred, and that is the end of this sample space. So it all the component will be composed of these elements. So here the first can be the tail as well, first head and then tail, two heads and then tail, and the termination strategy is also being shown here that three heads consecutively occur. Similarly, in part B, the set S equal to X is a continent. So we have to write the names of the continents. So S equal to what? So let me write the names of the continents. So let me write here first Asia, okay, then Europe, then Africa, Australia, okay, 1, 2, 3, 4, Antarctica, okay, and then North America, and the last one here will be South America. So 7 continents which have been shown here. So this is what? This is basically the number of the continents we have here. And the last part here is E. So we can see here that 1, 2, 3, 4, 5, 6, 7, 7 continents which have been shown here. The last part is here the set S equal to X such that 2x minus 4 greater or equal to 0 and X should always be less than 0. So here let me solve it here, and in solving it let me first remove this one. Okay, so this is part E, and here we have 2x minus 4 greater or equal to 0, which if 4 is added at the both sides, what I will get 2x greater or equal to 4, and dividing both sides by 2, I will get here x should be greater or equal to 2. Okay, but here simultaneously we have the condition that we have here and in and we should have x less than 1 as well. So in this set we can see that all the values of x are going greater or equal to 2 while the other are going less than 1. So therefore there is no value which lies in between 1 and 2, because here in this scenario, let me write this scenario with the help of this. Okay, so x should be less than 1, and here this should be greater or equal to 1, or let me use another color for it, this one. This should be greater or equal to this one, while here let me make it more clear. Here it will be like this one. Okay, because x is not included. So there is nothing which we can have here. Okay, and that's why here we will get what S will be the phi, or I can also call it the empty space, empty set. So here the sample space is the empty set. Okay, so that is basically the solution of question 2.1, and here we have seen that how to calculate or how to find different sample spaces if statements are given. So with the passage of time we will go beyond the sample spaces and probabilities, and we will dive into the details of more advanced concepts. So till then, take care of yourself, and I will see you with some more advanced concepts in our upcoming video. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 2.2 of chapter number 2, which is related to the probability. Okay, so the statement of this question is use the rule method to describe the sample space S containing of all points in the first quadrant inside a circle of radius 3 with center at the origin. Okay, so we have to use the rule method here to find all the points which are inside the circle of radius 3 and also in the first quadrant of that circle. Okay, so let me draw that circle here. So if I have here the 4 quadrants, okay, and this is the origin, so what do I have to do here? I have to draw a circle. Let me draw it by this point. So this circle I will have here will be just like this one, and here this point, this point, this point, and this also, these are 3 3 3 3. Okay, so where do I have to concentrate? I have to concentrate over this first quadrant, and here it is very easy to see that both, if this is, let me use this color. So if this is x-axis and this is y-axis, so then this is minus x and this is minus y. So I can see here that both x and y, these are greater or equal to 0. Okay. So this is what, this is the first quadrant, and here I have to find out the sample space in which is confined here at this point. So therefore, in order to do so, I have to start writing the sample space, and here in this area all the points will be composed of 2 points which will be x and y. Okay, all the points here will be composed of x and y. So therefore, I have to write x y such that, okay, such that what I have to write the formula for the circle, and for the circle I know that the formula for it is x square plus y square is equal to r square, where r is the radius of this. So here I have to confine all the points here. So therefore, all the points x square plus y square, these would be the distances from of the edge of this edges from this origin. This should be less than or equal to what, 3 square, okay, which will ultimately give me what, which will ultimately give me 9. Okay, and also here another condition is that this is true for all the points which are residing in all this circuit. So therefore, in order to confine it here, I know that the condition here is that both x and y should be greater than 0. So therefore, in order to end it, I have to write here x should be greater or equal to 0, and similarly y should be greater or equal to 0. And that is basically the rule based method which is defined here for this question. And it is important to know that how to write the mathematical equations for the sample spaces and all the rule based methods. So that's it for today, in which we have seen the description of the sample space by using the rule based method. So I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 2.3, and here we have to find that which of the following events are equal. So we have some events which are listed as part A, B, C, D. So in part A, the event A has been written explicitly, while in B, C, D we have some statements and the implicit representation of the set. So therefore, in order to compare them easily, what do I have to do? I have to write them in the explicit manner. So therefore, starting with part B here, so what is this here? X, B is equal to x, such that x is a number on a die. So on a die we have what? Let me use this blue color. So on a die we have how many numbers? So I have numbers which starts from 1, 2, 3, 4, 5, and 6. So this is the sample space which represents event B. Okay, so that is what we wanted to find. Similarly, in part C, what do I have to do? I have to see that C is equal to x, such that x square minus 4x plus 3 is equal to 0. So therefore, in order to solve it, we have to factorize it and find the factors of this equation. So therefore, in order to factorize it, let me write it here: x square minus 4x plus 3, that is equal to 0. So let me factorize it: x square minus 3x minus x plus 3, and that is equal to 0. And now, in order to find the commons of them, so x minus 3, and similarly minus 1 x minus 3, that is equal to 0, which will ultimately give me x minus 1 and x minus 3, that is equal to 0, and ultimately it will give me how many points? It will give me 2 points, which would be 1 and 3. Okay, so therefore here C would be what? In order to write this C, what values would it have? It would have 1 and 3. So this is set C. Similarly, statement D or part D of my question is that D is equal to X such that X is the number of heads when 6 coins are tossed. So how many heads can I have if 6 coins are tossed? So let me write it D. So I may have 0 heads because that is also the possibility that 6 coins are tossed and I don't get any heads here, and all of them will be tails. I may also have 1 heads out of these 6. Similarly, 2 heads, 3 heads, 4 heads, 5 heads, and also I may, this is also the possibility that I may have get all heads. Okay, so that is 6. Okay, so therefore this is what, this is D. So similarly, I have here A equal to 1 3, and B is this, C is 1 3, D is 0 to 6. So therefore it is very easy to see that the A and C, these two are equivalent. Okay, so therefore I can see that this A and C, these two are equivalents, and therefore all others are distinct. So that's it for today, in which we have to find out the explicit representation of the sets or sample space from their implicit representation. So that's it for today, and then I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 2.4, and the statement of it is an experiment involves a tossing an experiment involves tossing a pair of dice. Okay, so we have a pair of dice or 2 dice. Okay. One green and one red, and recording the numbers that come up. Okay, so the experiment is basically tossing a dice, and we have to note the numbers which come up. If X equals the outcome on the green die and Y the outcome on the red die, describe the sample space as A by listing the elements X, Y, and B by using the rule method. Okay, so let me start solving it first by using the listing the elements method. Okay, so here we can see that all the elements here will be composed of X and Y, and these will be from 1 to 6. So first of all, the first I can get will be 1 1. Similarly, I can have 1 2, I can have 1 3, 1 4. Okay, and also 1 5 and 1 6. Okay, so this is for the toss in which X is 1 while Y can grow from 1 to 6. Similarly, X can have a value 2, Y 1, X is 2, Y 2, X is 2, Y 3, 2 4, 2 5, 2 6. Okay, similarly, when X is 3, it is 1. When X is 3, this is 2. Okay, and up to what, 3 6. Okay, and similarly it can go from 1 to 6, where X can have value 6 1, 6 2, 6 3, all up to what, 6 6. Okay, so that would be the end of this. Okay, so it composed of all the sets of, or all the elements which are 1 and 2. So this is what, this is the listing the elements method. Similarly, part B here is that we have to use the rule based method. So this is what, this is set S, and here we have to list a pair of numbers X Y. Okay, and such that X is greater or equal to 1 and less than or equal to 6. Similarly, I also have another element which is Y. So y should be greater or equal to 1 and less than or equal to. Okay. So that is basically the sample space S. Similarly, I can also write it like xy such that x and y both are greater or equal to 1 and less than or equal to. So that is the answer of my question, and that is what we intended to find out, and I will see you with some more interesting stuff in our upcoming video. Welcome back, guys. I hope all of you will be fine. So this is the second chapter of our book, and here this is question 2.6. So two jurors are selected from 4 alternates to serve at a murder trial. Okay, so out of the 4 judges, we have to select 2 judges or 2 jurors in a murder trial. So using the notation A1, A3, for example, to denote the simple event that alternates 1 and 3 are selected, list the 6 elements of the sample space. So it is already stated that there will be 6 elements in this sample space. So how would it be 6? So let me have here the scenario in which we have some judges. So let me start them from A1, the first juror, then A2, then A3, then A4. Okay, so what are these? These are basically the 4 jurors, and for them I have to select any 2, and then the selection process has to take someone such that A1, A2 is equivalent to the A2, A1. Okay, what does it mean? That the order doesn't matter. A1 and A2 juror means A2 and N1, and that is what we have to do. So let me have here the juror, one of the juror will be A1 and second would be what? So let me first take the first juror. Let me select this color for it. So this will be A1, and with it first let me select A2. Okay, so what I will get from it I will get, let me use this color here as well. Okay, so here I will get what? I will get A1, A2. Okay, because the combination of A1 and A2, then after it the combination of A1 with A3. So what I will get here? I will get here the second one here. Here I will get what? It will be A1, A3. Okay, and after it its combination with the fourth one, and here what I will get? A1, A4. Okay, so it is already given that what I am getting here, A1, A3, A1, A2, and now A1, A4, and it means that A4, A1, A3, A1, A2, A1, these are all equivalent. Okay, so this is the first combination, and here we have got them. Now again I have to take A2. Why A2? Let me tell it to you guys. Now A2, and now I cannot go back because with A2 I will have, let me first check that if I will have A2 and A1 and I write it here, what? The first combination, just like A2, A1. So you can see that here this one is already selected as A1, A2, therefore it cannot be like A2, A1. So therefore I have to remove it. Okay, and this branch as well. Okay, so I have to remove this branch as well. So let me remove it. Okay, so now it is removed. So what I have to do? I have to go to the right side. So now going to the right side, the first combination here will be with A3. Okay, so let me draw those boxes with this one, and the first combination here will be A2, A3. Okay, the second one here will be with A2 and what? A4. So this is what? The second one, and here what I will get? A2, A4 as well. Okay, so this is what? This is the combinations of all of them here. Okay, now the last one here is this one. Let me select this color, and this is here A3. Okay, you can again see here that if I will go to the left one and start making the combinations of it with a1 2, I will see that with a3 a1 I also have a combination here as well. With a3 a2 I also have a combination here as well. So as I have previously told you that the sequence of the combination doesn't matter, so therefore a2 a3 means a3 a2, so therefore I have to go to the right side and the only combination it will make it with the a4. So therefore the only one combination here will be what? That would be a3 a4. Okay, so that's what we have all the sequence, and there is no other option here with us, and the last one here is this one, and it will stay alone because it is the only judge we have here. So therefore these are all the options, and I can count them here as well. So this is 1, this is 2, this is 3, this is 4, 5 and 6. Okay, so what is this? This is basically the concept of the combination. Okay, can be. And I will also get back to this point in our upcoming videos. So till now you have to keep in your mind that in combinations order doesn't matter. Okay, in any sequence order doesn't matter. It means a1 a2 means a2 a1 as well. Okay, so that's what we have. So now in order to write the sample space here, as what will I have here? I will have a1 a2. Okay, let me write them here, a1 a3 and then a1 a4 a1 a4 a2 a3 a2 a3 then a2 a4 a2 a4 and now writing it here the last one where that one is a3 a4. Okay, that is a3 a4 and now closing it with this, and that is what this is basically the sample space for the question which is asked here. Okay. So that's it for today, in which we have seen the concept of the combinatorics, and the combination is the concept which we have discussed here. And I will also talk about these same concept in our upcoming video, and what is the difference if we would have the concept of the orders and sequences and whatsoever. So thank you so much, and I will see you in our upcoming video. See you soon. Welcome back guys, I hope all of you will be fine. So again, very interesting question here as well, and that is question 2.7 of the probability. So what is the statement here? So 4 students are selected at random from a chemistry class. Okay, so there can be the number of students in a chemistry class, and from those students we have to select 4 students and classified as male or female. Okay, so either that would be male or female. So list the elements of the sample space S1. So S1 should be the sample space here using the letter M for male, and for female I have to use F. So define a second sample space. The first one is when defined, there is a second part of it, and here in this part define a second sample space S2 where the elements represent the number of the female students. Okay, so that is not present here, but here we have to represent the number of female students. That is misprinted here. So that is for S2. So here we have to select the 4 students. So therefore in our convenience, let me have a window in which I will have what? 4 slots. Okay, so there I have 4 slots. In these slots we can have the any number of students here. So in the first slot, this is slot 1, this is 2, this is 3, this is 4. So here in first slot, how many option would I have? So I can either have here male or female. Okay, either I will have here male or female. Okay, so let me write it with any other color. Let me use this one. So either I will have here female or male option. So therefore here I have what? I have 2 choices. Similarly here in second slot, how many choices would I have? So again, the replication is allowed because I can also have here male or female student, and that is also a random sampling. So therefore either female or male here as well. In third slot, I can either have female or male, and similar options are available for the fourth slot as well. So in each slot here I have two options. Yes, so these are basically the two options, and here it would be male or female, and male and female, and male or female, and male or female. So what is this? I can see that here I am applying the concept of and here as well. Okay, I can see that it has been and so therefore I have to multiply them together. This is the AND operation, and multiplying them together and seeing that what is it. So it would be 1 plus 2 plus 3 plus 4. So if the bases are same, the exponents will be added together and only a single base has to be written here. Okay, so the single base here is 2, and the addition of the exponents will give me 4, which will ultimately give me the 16 possible combinations of all these points. Okay, so what would be those combinations? So let me start writing them here, and let me represent male with this orange color, and female, this will be male, and female with this blue color. Okay, so let me start writing them, and let me have in first slot all the elements I would have would be male. So male, 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 and male. Okay, so the first one is male. Then in second one, let me have male, 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 and the last one here is the female. Okay, then let me have here male, male, and here at this option I will have female. Okay, and here the male. Okay, and similarly here in the fourth one I will have here male, male, and here what would I have? I have here female and female. It can also be an option here as well. Okay, so after it, what will be the options? So I will have here male, then the female, and then male. Okay, similarly here I will have male, and here female, and then again male, and then female as well. Similarly here male and female, and here female as well, and here. So in the last one, what would I have? I will have here male, and here female, female, female. So how many combinations I have here? So it is 1, 2, 3, 4, 5, 6, 7, 8. So 8 other combinations are left, and let me start writing them here. So the next combination here would be what? So let me start here with this female, and then with all the male, male, and okay. So then again female, okay, and then male, male, and the last one here would be the female. Then again female, okay, and then male, then again female, and male here as well. So you can see that I have been replicating the male or female here as well. So female, and here let me write here male, and the last two here would be female and female. Again here female, female, and the last two would be male and male. Okay, and here female, female, and here male and female. Then female, 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 and male, and the last one here would combine all the females, and this is also another option what we have. So here we have, this is 9, 10, 11, 12, 13, 14, 15, and 16. Okay, so what is this? This is basically the combinations which are basically showing me all the possible outcomes of randomly selecting 4 students out of a class, and those students could be male or female. Okay, so in that here what I would have, so let me remove these sequence numbers because a sample space could not contain them, and it would only contain the sequences what we will have. So these are all the combinations which I will. So these are all the combinations, and in binary communication, if I can write here m with 0 and female with 1, so I can see that in any binary or digital communication systems or in digital arithmetics, I can see that those would be 0 0 0 0 0 0 1 0 0 1 0 up to what I will get here 1 1 1 0 1 and then 1 1 1 1. So this would be the same case here. I have got. Okay, so the same scenario, and the how to write the replicating combinations of any binary items, I have shown you the procedure of writing them here, and the same will be followed in any scenario where I will have 2 items. Okay, so that is what that is we have here. This is S1. Similarly, here I can see that here the number of females are 0, here the number of females in these two cases, and here, and in many cases like here I have number of females equal to 1, then here, okay, and here we have number of female equal to 2, then I also have here number of females equal to 3, and here 4. So the number of female I would have here in as mentioned and asked in the second part of this question, I may have 0 number of females, I may have 1, I may have 2, I may have 3, and also I may have 4 number of females, and that is what that is S2, and that is also the answer of second part of my question. Okay. So I hope you have understood how to write different combinations of the items which are 2 in number, and how to replicate them if the order has some meaning in it, and also these are basically have been shown multiple times. If one item has been shown in one position, that item can also be shown in the other locations as well, because replication is allowed. So that's it for today, and I will see you with such stuff and such interesting stuff in our upcoming videos. We will discuss them, and if you have any question, you may ask me in the comment box. Thank you so much, and I will see you soon. Welcome back, guys. I hope all of you will be fine. So this is question 2.10, and the statement of it is, an engineering firm is hired to determine if certain waterways in Virginia are safe for fishing. Okay, so samples are taken from 3 rivers. So we have 3 rivers from which the samples have been taken. So list the elements of a sample space S using the letter F for safe, okay, and N for not safe to fish. Okay, so this is part A. Let me first try to solve part A here. So in part A, we have what we have a window containing the space for 3 elements. Why 3 elements? Because samples have been taken from the 3 rivers. So either those would be safe, just like F, and not safe, just like N. Okay, so what do we have to do? We have to mention all the combinations which corresponds with these 3 spaces. So what can be the options here? So let me first write what not safe, not safe, not safe. Okay, so this is the first combination. In the second one, not safe, and then safe, then not safe, safe, and not safe. Okay, similarly, what next? So not safe, safe. Okay, so the three first combination in which the rightmost location has been fixed with non-safe. Okay, so similarly, the next option, what do we have to do? We have to fix the last location or the MSB here with the safe option here. So safe and what? Not safe, not safe. Okay, similarly, safe, not safe, safe, then safe, safe, not safe, and the last one here would be safe, safe. Okay. So these are the overall options. So how many windows or how many rivers do I have? I have 3 rivers. So in order to find the options or the number of items in the sample space, what do we have to do? We have to write it 2 raised power 3, so it will give me 8. So let me see that the total number of the items in the sample space are 8 or not. So we can see here that here 1 2 3 4 5 6 7 8. So 8 items here. So let me close it, first and last one, and writing commas at the end of each item here. What would I get? This is a sample space which is S. Okay, so this is the solution of part A. Similarly, in part B, what is asked is list the elements of S corresponding to event E. Okay, so now another sample space or another set which is E, which is basically the subset of S, that at least 2 of the rivers are safe for fishing. Okay. So we have to select here the items in which 2 of the rivers are safe or 2 F's are present. So let me mark down them here first. So here no river is safe, no river is safe, one river is safe, one is saved, and here we can see that 2 rivers are saved. Okay, at least 2 means 2 or more than 2. Okay, here this is 1, this is again 2. Okay, we can see that this is again 2, this is 2. Okay, and this one is here, this one is 3, which is greater than 2. So at least means greater or equal to. So now let me solve it here. So here the E will be equal to what? Let me write these samples here. So NFF, NFF. Okay, the second one is FNF, F and F. Okay, then FFN, FFN, and the last one is triple F. Okay, so we can see that here we have the condition that at least 2 of the rivers are safe. So at least 2 means 2 or more than 2. Okay, and the last one here is that define an event that has its elements, the points which are given here. So we have to write the statement for this. So let me see that what is common here. So by looking at it, we can see that all the items in the middles are basically F. Okay, this is common in between all them. Okay, so we can see that among all of them I have this F, which is in mid river. And what should be the statement here is that here it is showing me that the second river is basically safe to fish. Okay, so what should be the statement here? The statement for it is second river is safe to fish. Okay, or safe for fishing. So this is what? This is the statement for part C. So I think the conceptual overview of the items related to this question are now clear. So if you have any question, you can ask me in the comment box. Till then, take care of yourself and I will see you soon.